Dear student, in this lecture video, we studied about the objectives of the power system operation control and various controls used in the power system. First, introduction about the power system operation and control. So there are two power system is the AC power system and a DC power system. What is the all the power systems are interconnected only. It is called as a interconnected power system. The AC power system become most popular than the DC power system because of the following reasons. The AC generators are simpler than the DC generators. You already studied in the basic electrical engineering in first year, and then the second year and third year you studied the AC and DC machines of the electrical machines. Okay, so the DC generator or AC generator construction, the two main part is the stator rotor, that is the armature and field. Okay, the commutator is used in DC, and then the DC field excitation is required for AC. This is the difference between the AC generator and DC generator. The AC generator are simpler than the DC generator. That's why the AC system become most popular than the DC system. And the second one is the transformation of voltage level is simple, providing great flexibility of different voltage levels at generation, transmission and distribution. If the power system means it consists of generation, transmission and distribution only, three parts only. Okay, what we have to transmit from the generation station voltage level at a different level, that is 10 kV, 11 kV, 32 kV, 60 kV, like that. If the voltage is AC, okay, the transformation of voltage level is simple. Okay, and then it is great flexibility compared to DC, because the AC is converted into DC with the help of a converter. Okay, so compared to AC voltage level transformation is simple than the DC. That's why the AC system most popular than DC. The third one is the AC motor is widely used, which is very simple construction and then simpler and more economical than the DC motor. Because of these reasons, the AC power system become most popular power system for use by the consumer over the DC power system. Okay. Then what is the objective of the power system control? Okay. So the control of the power system is very, very important. Okay, already I told what is the objective. We maintain the reliable, we give security to the power system, and then we maintain the frequency and voltage, and we maintain the uninterrupted of the power supply. That is the continuity of the power supply. This is the objectives of the power system. Then how to control this one? Now you see the PPT. That means the first one is the system must be able to meet continually changing load demand for active and reactive power, because the industrial load consists of both active power and then reactive power only. Okay, so therefore the types of energy, the electricity cannot be conveniently stored in the sufficient quantity. That means day by day the demand of electricity is increased. So therefore the adequate spinning reserve of reactive and real power should be maintained and controlled at all the times, that is throughout the day, based on the load curve. Okay, so the spinning reserve later we studied in the constraints in unit commitment, that is the third part of the model 1. Okay, then the second one is the system should be supply energy, that means at minimum cost and with minimum ecological impact, that is the economical. So okay, the quality of power supply must meet the certain minimum standards, that is constancy of frequency, that is maintain the constant frequency, that is 50 Hertz. The second one is constancy of voltage, that is constant voltage. The third one is the level of reliability. Okay, So these three we have to maintaining constant frequency, constant voltage, and then a level of reliability. How we maintain the frequency? With the help of automatic load frequency controller. Because the interconnected power system is controlled by full and fully automatic generation control AGC. Shortest notation. Automatic generation control. The automatic generation control consists of automatic voltage regulator AVR and automatic load frequency control or controller ALFC. So the AGC, that means divided into two control AVR and ALFC. The ALFC means automatic load frequency controller is used to maintain the constant frequency even the load demand or the generation changed. And then how to maintain the constant voltage? That means automatic voltage regulator is used to regulate the voltage, that is the voltage magnitude. Okay, that is the procedure for maintaining the constant voltage. Then level of reliability. Okay, I already that means you studied in the power generation economics in the first sum. That means the reliable operation, that means the key concept of that is the reliable operations. Okay, the very important, because if the load vary, that is decreased, means definitely the reliable level of the reliable decreased only. Okay, based on the load variation. So therefore we have to maintaining the level of reliability. Okay, so the operation and the control of the power system should maintain the following. First one is stability. When we maintain the stability, the power system is in the normal state, then only we can maintain the stability. Okay, then the second one is security. How can we give the security? Even that means any risk or any maintenance, any contingency occurs in the power system, we have to maintaining the uninterruption of the power supply to the consumer. Okay, and it is the security is related to the robustness of the power system also. Based on these two factors you have to maintaining, we can easily give security to the power system. The third one is the reliability. Okay, the reliability is nothing but the probability of the satisfactory operation over a long period only. The reliability denotes the ability of the power system to supply adequate service on a nearly continuous basis. That means without uninterruption of power supply. Okay, so with a few intermittent interruption over an extended time period. Now you see what are the various controls used in the power system. Now you see the schematic diagram. Here that means three control is there. One is system generation control. Another one is generating unit control. Third one is transmission controls. Three controls used in the interconnected power system. Okay. First, in the system generation control, what is there? Load frequency control with the economic allocation. I already told the load frequency controlled by the automatic load frequency controller. Okay. What is the input of this block? Frequency, die line flow, and then generator power. Okay, then the output. So this is the schedule. We have to prepare the schedule, operating schedule, maintenance schedule, and then shutdown rule schedule. Okay, then supplementary control. That means from the system generation control, the supplemental comes to prime mover and control. Prime mover control means what? That means that is the generator, means the generating units means input is mechanical. So how can we give the mechanical power? From the prime mover only. So the prime mover shaft, the prime mover shaft is connected to the generator. Okay, both are coupled mechanically. So therefore the mechanical input is given to the generator with the help of the prime mover. Here what is the excitation system and control? We already know the AC generator, that is the alternator, the field is excited with DC power supply only. Okay, so therefore the DC power supply is required for field excitation of the generator. That is nothing but the excitation control. Okay, so what is the output of the generator? Voltage and then speed. Okay, the speed of the generator goes to prime mover, again controlled, then come back to generator. Similarly, the voltage, the speed or power goes to excitation. By varying the field excitation, okay, the field current of the generator vary. Finally, we can control the voltage, speed. Okay, the speed is directly proportional to power. Because the power P is equal to torque into omega. This is the formula, general formula. Omega is the angular velocity, that is the speed. So therefore the speed is directly proportional to P is equal to power is equal to torque into omega. So therefore the speed is directly proportional to the power. If we control the speed with the help of the prime mover, we can control the power of the generator. Okay, here under voltage only will cause the current. Okay, we can control the field current with the help of the excitation, that is the excitation system control, that is the exciter. Okay, then we can control the voltage of the generator. Okay, then the output of the generator is electrical power. It comes to transmission control for transmission purpose. This is nothing but the another generating unit and associated control only. So the transmission control is nothing but reactive power, voltage controller, HVDC transmission and associated control only. What is the output? Frequency, diflows, generated power. Again these three terms is fed back to the system generation control. This is the closed loop only. So here what are the various control? System generation control, generating unit control and then transmitter control. Three types of the control is used in the power system. Okay, so dear student, I hope that in this lecture video you clearly understand the objectives of the power system, what is the introduction about the power system operation and control. Okay, and a control is very very important. First we plan the power system, we install the power system, then generate the power by the power system, then we can control. That is also is very very important. During a disturbance occurs, the disturbance may be generator outage or transmission line outage. Okay, therefore various controls and the objectives of the controls, that means we detailedly studied in this lecture video only. Thank you student for listening this video.